Hi, in the last session, we talked about MMTC use cases, and we also talked about MMTC characteristics to serve in 4G and 5G networks. Now, let's explore the 5G cell and understand how the concept of a cell has evolved in 5G technology. A cell is a geographical area over which a certain base station provides the coverage for the telecommunication network. At the very beginning of wireless communication, omnidirectional antennas were used, and they were represented by a hexagon with a base station in the center. However, later we started using cell sectors to increase the cell capacity and coverage. Now these three sectors are called individual cells, and these corresponding to the one base station. At the bottom picture, this is a better representation where a base station is placed at the corner of the hexagon, and now it has three hexagons. Each hexagon represents individual cells. In 5G, we have a new concept called beamforming. So the concept of a cell is further evolved for this purpose. We will see that in some time. Now let's talk about cell search. So when a UE or device is turned on or when it moves into a new cell, then it has to synchronize with the serving cell, and it has to obtain basic information about the cell like system bandwidth, etc. This is the initial step, and this synchronization must happen before any transmission or reception of data to the device. For this purpose of cell search, in LTE, each cell transmits two types of synchronization signals. These are the primary synchronization signal or PSS and the secondary synchronization signal or SSS. The UE listens to these signals to synchronize with the cell and obtain the physical cell ID. After synchronization, the next step is to acquire the cell system information. This system information is continuously broadcasted by the network, and this is essential for the UEs to access and operate correctly within the specific cell. The system information includes downlink and uplink bandwidth data. It also includes TDD configurations and parameters for random access. This system information is delivered by two different mechanisms and through two different channels. First is Master Information Block or MIB. MIB is delivered by the broadcast channel. And second is System Information Block or SIB. System Information Blocks are delivered through the downlink shared channel. Note that there is only one MIB type message, but there are several SIB type messages, SIB type messages like SIB1, SIB2, SIB3 and up to SIB9. When we talk about NR, we also have primary synchronization signal PSS, secondary synchronization signal SSS and master information block MIB, and we also have system information block SIB. However, to reduce the amount of broadcasted information, network only broadcasts very few information in broadcasting. So instead broadcasting all of the informations continuously, only a subset of this information is broadcasted. This is known as cell-specific information. This is the minimum amount of information that required for random access. The rest of the information is sent directly whenever they are needed. In NR, this similar concept is called SS block, which includes the primary synchronization signal PSS, secondary synchronization signal SSS, and master information block MIB. The main difference in NR is that multiple transmissions and reception points can transmit the same SS block, and hence they act together like one cell. Let's understand this with one example. So consider we have one base station that supports beamforming in 5G NR, and a small cell that does not support beamforming obviously, and one another base station that also using beamforming. Now if all of them are transmitting the same SSB, then they will act like one single cell. So when a UE moves from one cell area to the another cell area, then the serving beam can switch from one beam to another beam, regardless they are a part of a single base station or different base stations. This allows flexible deployment options and reduces control signaling overhead, as mobility related signaling are reduced now towards the core network. Therefore, different transmissions and reception points are collectively treated as a single cell, as long as they are transmitting the same SSB. SSB can be either broadcasted or it can be beamformed if there is a coverage constraint. Okay, so that's it for today. In the next session, we will be talking about most important networking layer concept in wireless communication. We will be talking about RRC, and we will also talk about different RRC states in 4G and 5G. And we will see how the transactions happens between these RRC states. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.